Hello, fellow students. Today we're going to review the Cocke younger Kasami algorithm, which is helpful to know if some word belongs to a language determined by grammar, free context grammar. So, without more ado, let's go to the algorithm. I will share my screen. Okay, and here we go. This is the question that we have for today. We want to know if the word BBAAB belongs to the language determined by this grammar, right? According to the CYK algorithm. Here we have the grammar. As you can see, it has three variables, two terminals, and then three production rules. So the first step to apply the CYK algorithm is to be sure that the grammar is in Chomsky Normal Form, right? So this form takes this shape. We should have a variable that produces a chain of two variables, or a variable that produces a single terminal. This is an example of Chomsky Normal Form. To ensure that the grammar is in Chomsky Normal Form, we need to follow these steps, right? These 6 steps that we have here. So the first step is to remove lambda productions or epsilon productions, depending on the naming convention that you are using. If we go to the production rules, we see that we don't have any lambda production, right, or epsilon production. We don't have any variable that produces lambda or epsilon. So we don't have to do anything in this step. If we go to the second step, remove unit productions. A unit production is a production where a variable derives or produces a single variable. And in this case, as you can see, we don't have any unit production because all the productions produce a variable, a terminal and a variable, or a single terminal. So we don't have any unit production. Then we need to remove dead symbols. Dead symbols are the symbols that don't end up in a terminal, right? So for instance, here, as we can see, from the variable, the initial variable s, we can produce a terminal, and also from the other variables, we can produce a terminal and s. So in this case, there are not dead symbols. The fourth step is to remove inaccessible symbols. Inaccessible symbols are the symbols that we can't reach from the initial state. In this case, as you can see, we can go from the initial state to A, to the variable A, and to the variable B, right? We can derive to A and B. So we don't have inaccessible symbols. Anyway, if you have doubts, I'm planning on uploading more exercises where I will simplify grammars, and I will convert grammars to Chomsky Normal Form, because this is not the aim of this exercise, right? The aim of this exercise is to review the CYK algorithm. Although we need to perform these steps before, but we will go more in detail on these steps in other exercises that you can review on the channel. Okay, so once that the grammar is simplified, we proceed to convert it to Chomsky Normal Form. And for this, the first step is the substitution of terminals where it's needed. And in this case, it will be needed everywhere when they appear with a variable. So for instance, here we will need to replace the terminal A and B, that these two terminals, we will need to replace them with variables, because this production doesn't follow the convention to be in Chomsky normal form. As you can see here, it should be two variables and not a terminal and a variable. So we are going to introduce two new variables, x and y, to replace lowercase a and lowercase b in these productions, right? So the new grammar in Chomsky normal form takes this shape, right? We introduce two new variables, x and y, and then we replace lowercase a and lowercase b, which are the terminals, in all the chains, in all the productions where they appear, chained with another variable, right? So as you can see, we have made these 5 substitutions here, right? And if we check this grammar, as you can see, all the productions already follow Chomsky normal form, right? We have 2 variables or we have 1 terminal after performing all the substitutions here. So if we go to the next page, already with this grammar, we can start applying the CYK algorithm to this word. Okay, so once that we have the grammar in Chomsky normal form, we can apply the algorithm CYK. The most important concepts of this algorithm is that here we try to find if the word is generated by this grammar. And the way of doing this is starting by the terminals, and we will go we will go back from the terminals trying to reach the initial symbol of the grammar, right? The way of doing that is we are going to fill the rows of this table. In the lowest level, in the lowest row, we have the production rules that produce these terminals, and going backwards, we should reach the initial symbol on the first cell of the table. This is the first concept. The second important thing is the number of each cell. This coordinate tells us what we need to look on each step, right? So for instance, here, the first number tells me the position in the word. So here we are talking about the first position in the word, here in the second position, here the third position, and so on. And the second number tells the number of characters that we need to take. So here I'm taking 1 character. In this cell, I'm taking 2 characters, and so on. So when I reach the top, this is what generates, if I put myself in the first position, this will derive or generate 5 characters, right? So it's the full word. So that's why if I have the initial symbol here, means that I will produce the full word, and this word will belong to the grammar. Okay, so let's see this in detail. For instance, let's start filling the cells. for the first cell, I put myself in the first position and I take one character. So the productions, the variables that produce lowercase b are y and s, right? I have these two variables that can produce lowercase b. So we go here and we can generate this with s and y. In the next cell, we put ourselves in the second character and we take one character, which is lowercase b. And again, the variables that produce lowercase b are the same. For the third cell, we put ourselves in the third character, which is lowercase a, and we try to produce one character. So we look into the production rules and we see that the only rule that can generate lowercase a is x. So in this case, we type x here. In the fourth position, we have a lowercase a again. So this is the same as the previous one, right? The variable x is the only one that can generate lowercase a. And for the last position, we go to the fifth position in the word, take one character, and this is lowercase b. So again, is sy. Okay, so this is the easiest, the first row. Now we go to the second row. And in the first cell, in the second row, we start in the first position and we take two characters, BB. The only way of generating BB with a grammar in Chomsky Normal Form is with a combination of two variables. So let's type it here, right? When we are in the cell 1, 2, it means that we need to generate the chain that is starting from the first character and taking two characters. So to look into this, I look into the cell that represents the first character, and this is chained with the cell that represents the second character. And what we have on these cells is sy and sy. So to produce lowercase b and lowercase b, we have four possible combinations. We can do it with ss, with ys, with si, or with ii, right? We do it with any of these combinations. So if we look into the grammar, we look for variables that produce any of these combinations. And as you can see, we only have this one, which is b, right? So we can say that b produces ys. So we go here to this cell, and the only variable that can derive in bb is the variable b. So if we look into the grammar, right, let's say that we start by b. With this y, we can derive in lower b, and with s, we can derive in lower b, right? So from this b, we can derive lower b, lower b. We go to the next cell, and to get the content of this cell, we start in the second character and we need to produce 2 characters, right? Is the position 2, 2. So to do this, we can look into what is in the position 2 taking 1 character, and what is in the position 3 taking 1 character. And this is sy or x, chained with x, sorry. And the possible combinations are sx or yx. Now, if we go to the grammar, we can see how there is no variable that produces any of these chains, right? The most similar that we have is xs, but it is not the same. It has to be in the same order. So in this case, this will be empty because there is no variable that produces that chain. We go to the next one, which is the one that is in the position 3, 2. We go to the word, and in the position 3, we take 2 characters, which is lowercase a and lowercase a. And here we have to combine what is in the position 3 taking 1 character and what is in the position 4 taking 1 character. So it will be x and x. So the only possible combination is xx. So we look into the grammar, and there is no production rule that produces xx. So again, we will say that it's not possible here. And we go to the last cell of this row, which is the position 4, 2. So we go to the 4th character of the word, and we take 2 characters, which is AB in this case. And to produce this, we need to look into the cell 4, 1 and 5, 1. And now we have the variable x concatenated with s or y. Right, so the possible combinations are xs or xy. Again, we go into the grammar, and we have this one, right, which is generated by the variable a. So in this case, a generates xs. So on this position, we have a. Well, this way we have filled the second row, and we go to the next one, right? So now we need to look into the position 1, 3. So that means that we start in the first position, and we need to look how to generate 3 characters, BBA, right? So first position, 3 characters, BBA. And looking into this, now we can generate it in 2 different ways, right? So we are in Chomsky Normal Form. So that means that to create this chain, I can do it generating B and BA, or generating BB and A, right? It's all the combinations they can create with 2 different variables. And to create this, we can do it checking what we have in the position 1, 1, right? Concatenated with chained with what we have in the position 2, taking two variables, or we can do it taking what we have starting from the first character, taking two characters, and then starting in the third one, taking one character, right? These are all the possible combinations. So if we look into it, right, it means that when we generate this chain, we can take for the first character, and then we can take the two next characters, B and A, which is represented in this cell, or we can take the first two characters, we can generate the first two characters, and then we can generate the third one, right? We have these two possibilities to create this chain. So now we need to check all the possible combinations. In this case, it's empty, and in the second case, can generate B or X, right? So this is the only possible combination that we have, which is BX. If we look into the grammar, there is nothing that generates BX. So in this case, it will be empty. We go to the next row, which is 2, 3. And here we position ourselves in the second character, and we take 3 characters. So it is BAA. And again, we have two possible combinations to achieve this with Chomsky normal form. One is taking the first character, which is in the second position with only one character, and taking two other characters, which will be the third position, taking two characters. And the other option that we have is taking two characters in the second position and taking one character starting by the fourth position. So we take the combination of all the variables that we have on those cells to 1, 3, 2, which is 0, and 2, 2, which is 0, and 4, 1, which is X. And again, there is no combination here. There's no possible variable that generates this. We go to the third cell, which is 3, 3, and then we position ourselves in the third character, and we take 3 characters. So we should generate AAB. Now the possible combinations, right, to generate AAB are taking the first A and taking the other 2 characters, right? Or taking the first 2 characters, AA, and then generating the last one. So, as we mentioned, could be like taking the first character, generating the first character, and then the other two ones, or taking the first two characters, generating the first two characters, and then the last one. So if we look into the combinations, we have 3, 1, which is X. We have 4, 2, which is A. Or we have 3, 2, which is a 0. And we have 5, 1, which is SY. And the only combination that we have here is XA. If we look into the grammar, we can see how we can generate this from the starting symbol. We could say that S generates XA. So we go to the cell and we can fill it with S. Now we go to the previous row and it becomes a bit more complex, right? Because now we are in the first position and we take 4 characters. So how many combinations do we have now to create this chain with 4 characters? We have 3 possible combinations, right? So we can take 1 character and the other 3. We can generate 2 characters, the 2 first and the 2 second characters, or we can generate 3 characters and then 1, right? We have those 3 possible combinations. Anyway, the chain now is BBAA, and the possible combinations to generate this with Chomsky Normal Form are the first character, which is what is in the position 1, 1, and then the next 3 characters starting from the position 2, or taking the first 2 characters and then the second 2 characters, or taking the first 3 characters and then generating the last one. So we need to look to all the possible combinations, which are 1, 1 concatenated with what is in the position 2, 3, which is a 0, union the position 2, 1, 1, 2, sorry, which is a B, with the position 3, 2, which is a 0, union, which is in the position 1, 3, which is a 0, and what is in the position 4, 1, which is an X. Then, as we have 0 in all the possible combinations, we will fill this cell with 0. And we go to the cell 2, 4. So we need to generate we need to put ourselves in the second character, position 2, and then take 4 characters. So we need to generate all these string of characters, which is BAAB. So again, we can take the first character and then the other 3, start in 3, and we take 3. We can generate the first 2 characters, and then the second 2 characters, or we can take the first 3 characters and then the last one. All right, these are all the possible combinations. So we take, as I said, the first one and then the other 3, which is in the position 3, 3, right? And this is SY chained with S, or we take the first 2 characters and then generate the second 2 characters, right? So generate the first 2 one, and then the second pair of characters, which in this case is 2, 2, concatenated with 4, 2. And then finally, we take the first 3 characters, position 2, 3, where we have a 0, and then position 5, 1, where we have S and Y. So the only possible combination that we can reach is SS or YS. And if we look into the grammar, we can see that B can generate YS, right? So B can generate YS. So here can generate this chain with YS. And finally, we reach the top of the table, right? We reach the top of the table. This is like the most complex one because we need to find all the combinations to generate this word. So we could take the first character and with other variable, these 4 characters. We could take the first 2 and then 3. We could take 3 and then 2, or we could take 4 and then 1. So we have like many combinations here, right? Let's do them one by one. So if I'm in the position 1, 5, that means that I need to find all the possible combinations to create the full word, right? Starting in the position 1 with 5 characters, which is the full word. So we can start by the first character, and then we can concatenate what produces the other 4 characters. That's the first option. Or we could take the first 2 characters and then concatenate that with what produces the last 3 characters, which is starting in 3, taking 3 characters. Or we can take the first 3 characters and then And then what produces the last two ones, the fourth and the fifth. Or we could produce the first four characters and then the last one. Right, so these are all the possible combinations. Let's check one by one, right? How can we produce this? So it's what we have in the position 1, 1, concatenated with 2, 4, which is, sorry, why did I put here YS? Right, in 2, 4, it should be B, right? It's the variable that produces the chain, not the chain itself. So let's going back here, right? This is the first one, then what we have in the position 1, 2, which is B, and then 3, 3, which is S, and then what we have in the position 1, 3, which is 0, and 4, 2, which is A. What we have in the position 1, 4, which is 0, and 5, 1, which is SY. So this is all the possible combinations are SB, YB, or SI. These are the three combinations that we can have. So we go to the grammar and we check the variables that can produce any of these combinations. Right, so as you can see, we don't have SB or SY, but we have YB. And this is produced by the initial symbol of the grammar. So we could say that S produces YB. So we go to, sorry, I need to remove these brackets here. Okay, so we go to the first cell, and here, right, you can see how the initial symbol of the grammar can generate the full word. So in this case, we are already done. We have finished, and what we would say is that the word is generated by the grammar, and it belongs to as well to the language generated by the grammar, right? So if you have any doubt about how do we make these combinations, right? How do we make these combinations? What you have to think about is that right, you need to think about, for instance, here, how can we create this word with Chomsky normal form, with a grammar in Chomsky normal form, right? The possible ways of doing that of create that word is with two variables is, well, first I generate the first B and then BAAB. Another possibility is I generate the first two B's and then AAB, or I generate BBA and then AB, or finally I could generate BBAA and then B, right? So these are the four possibilities that we have. So it means that I could generate this word generating, with two variables, with a production rule, some production rules of this type. Right, in Chomsky Normal Form, could generate it with any of these combinations. So the only thing that I need to do is to see how I could do this, right? So in this case, it could be with what we have in the cell 1, 1, because I'm in the first position of the word taking one character, and then what I have in the position 2, 4, because I'm in the second position of the word taking 4 characters. This is one way, right? Then this is the first combination that we have here. Then the second combination would be in the first position of the word taking 2 characters, combine what we have in the third position of the word taking 3 characters, right? And so on. And this is the way of learning what do we need to write on each cell without having to learn this by heart, right? Just using logic. Well, I'm going to stop sharing my screen now. So thank you for joining me today on this exercise. If you have any question, you have any doubt, I'm planning uploading more exercises of this type to the YouTube channel. So as I will complete more exercises, you can check the other videos. Anyway, if you have any doubt, please don't hesitate to contact me, and I will try to answer. So thank you for being around, and I will see you soon in the next video. Bye-bye.